So in this next example, we're going to start using calculators to find logarithms. In the previous examples, we could just do it by hand because it was something simple like 3 to the 4 equals 81. But here, the problem might say, find or evaluate log base 5 of 30.1. And as soon as you see something like this, I mean, maybe you want to change it to an equation first, right? You say 5 to the x equals 30.1. But pretty soon, you ought to realize, well, there is no way you're doing this in your head, right? Okay, so time to bust out the calculators, and we've got this thing, and oh, there's a log button over there, see? It's got a log button on this thing, so we are set to go. We're going to use our calculator, and you start typing it in, and then you realize, wait a minute, the calculator button, the best I can do is say log of 30.1. And it'll give you some answer, but it won't be right. It won't be what you're looking for, log 5. We want log base 5, not just log. And here's what's going on here. Calculators are kind of old. Unless you have a new calculator, most calculators do not have a base function on them right there. Back in the old days, you had to figure out part of this by hand, and the calculator didn't really know what a log base was. It just knew what the logarithm was. So we're going to talk about how to sort of shoehorn this into old-fashioned calculators. And this is a useful skill for other reasons, but most immediately you'll find this useful in dealing with old calculators. And this is called the change of base formula. Okay? And the reason it's called the change of base formula is because we're changing the base. We have something where we say the log base b of some argument a, and here's what the formula is. We need to turn this into something the calculator can work with, and calculators only know about logs. They don't know about log base. So the way you do that is you turn this into the following equation. You say log of a, you leave out the base, and then in the denominator you put log of the base as the argument. Okay, so here's your change of base formula, and this is shorthand. What it really is the log with d as the base, and d could be any number, of a, and log d of the base of b. So what's happening here is I have changed my base from b to anything else I want, and that's d in this example, where d doesn't have to be related to a and b at all. D could be a million. Log base a million of a over log base a million of b. And there's reasons why this works, and it gets into, exponents and rules of logarithms and all that. We won't get into that detail. But you can basically use this change of base formula to get rid of that base b so your calculator can handle it. And this is as good a time as any to talk about what log actually is. When you have log base, where the base isn't specified, right? Does that mean there's no base? No, it's shorthand for something. Because obviously this wouldn't make any sense if you just had a blank there, right? What would that be? That would be like blank to the x equals a. It doesn't make any sense. So what this logarithm means when there's no base attached to it, it's just shorthand. It means log 10, okay? And log base 10 comes up so often in engineering and science and chemistry and those things. It comes up so often that people stopped writing log base 10 because they figured if there was no base there, well, they must have meant 10. So in this example, log a equals x, what that means is 10 to the x equals a. Okay, so if you ever see a logarithm without a base there, right, the base is blank, what they mean is log base 10. And all calculators know how to do log base 10, even if they don't know how to do log base 6 or 7 or whatever the base is. So you can change this into something the calculator can handle using the change of base formula. So let's get back to that example up here. I'm going to grab this guy and, no, that's not the guy I want. Let's just grab this guy and bring him down here, and we're going to solve this. Okay. So log base 5 of 30.1 equals x. Well, let's rewrite it using the change of base formula. This is going to be log of 30.1 over log And here we put the base in the argument. Log 30.1 over log 5 equals x. And if you just punch that into your calculator, you're going to get, let's see, I have it written down here. You're going to get 2.1154 as your answer. And there's more decimals, but those are the important ones. So 2.1154. And you can always double check to see if you're correct. That's the nice thing about logarithms. Remember how logarithms and exponents are inverse functions? You could say 5 to the x equals 30.1, and then plug in what you think x is, and say 5 to the 2.1154 equals, and if you plug that into your calculator, the calculator will tell you 30.1024, blah, 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 blah. And you can see, well, that's really close. The only reason it's not exactly correct is because I rounded this to only 5 decimals instead of 10 or 20 decimals. So this is how you do evaluations of logarithms using a calculator when they're ugly numbers, like log base 5 of 30.1 or whatever it is.